Hello everybody, I'm Nick, and today I'm going to talk about something called lowering. Lowering is one of those features that is very hard to explain just by using words, but it's very easy to explain by showing you how it works, and that's exactly what we're gonna do. Now, if you're not familiar with that feature, I can guarantee you're gonna have your mind blown and you're gonna understand the potential of diving deeper into your code and understanding more and more about how it works and what it does behind the scenes for you. And it will help you write more performant code by having the knowledge of what your code is doing. If you like that type of content and you want to see more, make sure you subscribe and hit the notification bell to get alerted when I upload a new video. So let's go straight into the code and let's explain what lowering is, right? So I have my program.cs here and I have an array with three items, three names, Nick, John, and Theodore. Now, something very basic in C# is the idea of a for each loop. So let's say for each of the items, I have an item and I can say console.writeLine, his name is, and then item, right? So iterate over the list of the array and print the name. But the interesting thing about the for each loop is that a for each loop is really a for loop if you think about it, right? So let's say you have items.length here, and you have var item equals items and then the index in the array, and you print it in a very similar fashion. So you say his name is that. But now if you think about it, right, a for loop is a while loop. So you have something like this, var I, because we have I above, equals 0, and then the expression would be pretty much the same. So I less than length, and then the same code inside of it. The interesting thing about the IL code that eventually this will be compiled into is that there isn't really the idea of a loop. It's basically a bunch of statements and go-tos. So there's not a definition of like code block, which means that instead of going into the trouble of creating a unique way to create IL code for a for each loop, and then unique IL code for a for loop and unique IL code for a while loop, all of these three pieces of code will be lowered. So from a high level feature to a lower level feature within the same language, still C#, they will be lowered to a while loop. And I can prove that by going to sharplab.io, which is a website which I highly recommend you check out. And I paste these three loops in here, and if I scroll down, you will see that all three of them, I think I'm actually hiding a part of the code. So let me just populate this with a bunch of noise so it pushes the code up. So let's ignore that. Right, so now I can scroll and you can see that the code on the left is the original code for each loop, for loop, while loop, and the code on the right, it's the exact same thing three times, right? With the for each loop and a feature called string interpolation being translated to string concatenation. The for each loop is also translated into a while loop, and then the while loop is a while loop, so it doesn't really get translated into anything. It's just being lowered to itself. And that is the idea of lowering, taking high level features of a language and converting them into lower level features of the language, so we get more mileage out of the IL code that the compiler needs to generate to have more features. So let's say you have something like a switch on strings, right? Well, switches on strings don't really exist in C#. You've been lied to. So let's go back to the code and actually show that, right? If I remove this, and I can keep that array there, and if I say, I don't know, something like var random equals new random, and then I pick a random item, right? So item equals random dot, here we go. So I pick a random item, and if I say switch on the item and have something like case Nick and have the same printing logic, so console writeLine, his name is, I'm just going to use the variable. So what is it? Item. Here we go. And then break. And if I do this 3 more times with John and Theodore, right, we have a switch here. But a switch on strings doesn't really exist. what actually exists behind the scenes, and you might again be very surprised about this, is that this switch will be turned into if-else statements. If else, if else. So the code that you actually wrote that will actually be compiled is if-else statements. So if you're using a switch thinking, oh, it's going to be super performant because it's going to go straight from item to the thing I want it to go, then you're wrong. But here's where the more interesting thing comes in, right? So let's say we had more cases here. So let's say I had another one for, I don't know, Mike. And then let's say I had another case for, I don't know, Ahmed. We are still using if else, if else, if else. And let's add another one. We're going to call this one Jacob. So we're still with 6 cases. We are if else, if else, if else. But, and I'm sure you're going to be very interested in this, if I have a last one called Attila, then look what lowering does. It will use a compute string hash function on the text and then generate an unsigned integer out of that. And then it will effectively build a graph to traverse if the number is bigger or smaller, or if it matches a specific number, to optimize how the if-else branching will perform. And this will persist across any other amount of items in a switch, all because of lowering. So you're given the syntactic sugar of writing awesome C#, and lowering is removing the sugar to facilitate something on the IL level without having to do a lot of implementation specific to each feature. So things like, let's say, records, right? That's another big one. A record isn't really something special. All it really is behind the scenes, and I can just show you here, is it's a class with very specific things implemented around it. So record, let's say example record here, and here we go, we have the record here, and ignore all this compiler generated attribute stuff. This is still related to records, but this is not a record class. The record class is here. So as you can see, all a record is a class that implements the equitable, I think that's how you pronounce that, in a very specific way, and then it has things like a toString, which is overridden, some virtual members, overridden operators, so it can do checks based on the properties, not based on the reference, and a lot of other stuff. And if I keep adding properties, let's say actually I can't do this here, let's say public string, let's say name, get init, then that is taken and it's put into all the other things like the backing field, the quality check, print members. It writes all that code for us. So when records were introduced, there wasn't something really on the IL level that changed. It was all on the pre-compiling level during the lowering stage. And lowering is taking care of so many things that you might take for granted. For example, var doesn't exist outside of C# really in the CLR. So if I say var text equals string.empty, for example, then you see that this is just translated into string. It's not something magical there. You write var, it's converted into string. And that is the same for so many features. For example, what's another one? Let's say the using statement. If you have something that is disposable and you have a using statement, then you have something like this. And you disposable isn't really a class, so I would have to create this. And all that really is a try with a finally that calls the dispose method of the disposable. It was always that, and the introduction of the feature was just syntactic sugar that is being removed during lowering. Now, why do I say that this feature can predict performance? Well, I say that because once you understand how the code that you write is being lowered before it's even compiled properly to IL code, then you can start seeing patterns on how to optimize things. And by knowing how your code is lowered, you know what to use and what not to use in hot paths and things that actually mean something to you when it comes down to performance. This feature is never ending. Link is the same. It's just a bunch of extension methods, and the for something select something is also being lowered twice, once to the fluent link version and then to extension methods. Now if I do the insane thing to change this from a void to an async task, then you're gonna have your mind blown, because you're gonna see the state machine and all the await async states. You can see it here, by the way, if you're really interested in it, but I'm just conscious that you might have a seizure by looking at this, so I'm gonna remove it from the screen right now. But I hope I made you aware of such a huge thing about the compiler and the compilation process, because it's just one of those things that are not talked about. And every time I see a new feature being released or coming in C#, all I'm thinking is, okay, this has to be lowered somehow. How is it being lowered? And lowering not only gets more mileage out of the IL for free, but it also gets more performance for your code, as you saw on the switch example. So I highly recommend you try your own things. I'm gonna leave a link to Sharp Lab in the description down below so you can try it out. It is an amazing website, and I highly recommend you give it a star on GitHub as well. And if you want me to make more videos like this where I dive deeper into the compiler, maybe we want to see something on the JIT as well, please let me know, and I'm more than happy to do that. That's all I had for you for today. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.